Rough idle occurs when your engine shakes or vibrates noticeably while stopped, typically at stoplights. This indicates unstable engine operation at low speeds between 600 and 1000 RPM. About 20 to 25% of U.S. drivers experience this issue annually. This problem doesn't occur in electric vehicles, which eliminate idle altogether. The main cause of rough idle is an imbalance in the combustion process. This means the air-fuel mixture, ignition timing, or mechanical condition isn't optimal in one or more cylinders. Addressing this imbalance is key to smoothing out the idle. Spark plugs and ignition issues are key contributors to rough idle in vehicles. Worn or fouled spark plugs prevent efficient combustion, causing misfires that disrupt engine smoothness. Spark plugs should be replaced if the electrode gap exceeds 0.05 inches, as this reduces ignition efficiency and leads to incomplete combustion. These misfires are a major cause of rough idle, accounting for 12% of vehicle recalls in 2025, according to recent data. Fuel delivery problems in modern engines often stem from clogged fuel injectors or a failing fuel pump, disrupting the precise flow of fuel to the engine. Clogged fuel injectors are a common issue. These components spray precise amounts of fuel into each cylinder for combustion. When clogged, they can't atomize fuel properly, leading to rough idle, engine misfires, and inconsistent RPM. Several factors cause injector clogs, including hydrocarbon deposits from gasoline, rust in the fuel system, faulty windings, and damaged springs. Modern engines rely on electronic fuel injection, or EFI, for precise fuel delivery. This system includes the fuel supply, a filter to remove contaminants, a pump to pressurize fuel, a regulator to maintain pressure, and injectors that spray fuel into cylinders, all controlled by the engine's computer, or ECU. Here's a diagram showing the fuel injection system components and their connections to sensors and the ECU. Ethanol-blended fuels, common in the U.S., attract moisture and promote corrosion in fuel systems. This can cause clogs in injectors and failures in fuel pumps, particularly in older vehicles not designed for high ethanol content. This image shows corroded carburetors affected by ethanol, illustrating the corrosive impact on fuel system components. A failing fuel pump can't maintain the required pressure for proper fuel delivery. This leads to weak acceleration, engine stalling, and rough idle. Common symptoms include damage to pump components, such as irregular holes. This image highlights symptoms of high-pressure fuel pump failure, showing damaged components with irregular holes. To address fuel delivery problems, use fuel system cleaners regularly to prevent clogs. For severe issues, professional injector cleaning or replacement is often necessary. Always monitor systems with OBD scans and consider ethanol-resistant parts for better longevity. Dirty air filters restrict airflow into the engine, preventing proper combustion and causing rough idle. Engines require a precise air-fuel ratio of 14.7 to 1 for optimal performance. Deviations cause rough running and poor efficiency. Vacuum leaks introduce unmetered air into the system, diluting the air-fuel mixture and causing rough idle and shaking. Regularly inspect vacuum hoses for cracks and replace air filters to prevent these issues. Sensor malfunctions are a common cause of rough idle in vehicles. When sensors like the oxygen, mass airflow, or crankshaft position sensors fail, they send incorrect data to the engine control unit. The oxygen sensor, also called O2 sensor, monitors oxygen levels in the exhaust. It helps the engine control unit adjust the air-fuel mixture for optimal combustion. When faulty, it provides incorrect readings, leading to either too rich or too lean mixtures that cause rough idle. The mass airflow sensor measures the amount of air entering the engine. This data is crucial for calculating the correct fuel injection amount. A faulty MAF sensor sends inaccurate airflow readings, resulting in improper fuel-air mixtures and contributing to rough idle vibrations. The crankshaft position sensor monitors the position and rotational speed of the crankshaft. This information is essential for proper ignition timing and fuel injection. When this sensor malfunctions, it causes the engine control unit to make incorrect adjustments, leading to misfires and rough idle. When any of these sensors fail, they send incorrect data to the engine control unit, or ECU. The ECU then makes erratic adjustments to fuel mixture, ignition timing, and other parameters. resulting in the rough idle and shaking experienced at stoplights. Sensor malfunctions are often easily detectable through onboard diagnostic or OBD scans. These scans read error codes stored in the vehicle's computer, allowing mechanics to quickly identify which sensor is faulty and needs replacement. Mechanical wear and tear is another major cause of rough idle in vehicles. Components like timing belts and cylinder compression systems can deteriorate over time, leading to vibrations and shaking. Worn timing belts are a common mechanical issue. These belts keep the engine's valves and pistons perfectly synchronized. As they wear, the timing becomes imprecise, causing misfires and noticeable vibrations, especially at idle speeds. Low cylinder compression occurs when pistons, rings, or valves wear out. This reduces the pressure needed for efficient combustion. As a result, the engine experiences incomplete burning of fuel, causing shakes and vibrations, particularly when idling. Both of these mechanical issues are amplified by engine harmonics. At idle speeds, engines produce vibrations in the 10 to 20 Hz frequency range. These low-frequency harmonics resonate through the engine mounts, making any existing imbalances feel much more pronounced as shaking. When diagnosing rough idle, start with an OBD scan for error codes like P0300 for random misfires. This quick check can reveal ignition or fuel issues. Next, perform visual inspections of the engine components. Look for worn spark plugs, dirty filters, or loose connections. Fuel pressure tests help identify issues in the fuel delivery system. Use a gauge to measure pressure and check for clogs. Proactive maintenance prevents issues from escalating. Hybrids show 50% fewer idle complaints due to better systems. AI-driven predictive diagnostics are becoming common, anticipating failures and reducing downtime. For older vehicles, consider annual tune-ups to maintain optimal performance and prevent rough idle.